Welcome to the Deep Dive. Today we're going to be looking at The Art of Doing Science and Engineering by Richard Hamming.
Oh, yeah. I've heard of that one.
Yeah, it's a fascinating book. And not exactly a light beach read, though.
Yeah.
It's a collection of lectures from a really brilliant mind. Hamming was a mathematician at Bell Labs, so right at the heart of early computing.
Yeah.
And known for his really insightful thinking.
Yeah, and it's funny because this book isn't like all about equations or anything. It's more about a way of thinking that leads to breakthroughs.
Yeah.
So, Hamming's focus was really on the style of thinking.
Yeah.
That really helps people make an impact.
Right. So we're not just going to summarize the book. We're going to try to extract that mindset. You know, those strategies that helped Hamming do truly remarkable things.
Exactly. And maybe it can help our listeners too.
Yeah. And so we're gonna be tackling some pretty big questions. What separates a great engineer from an average one? Can you actually predict the future with some back of the envelope calculations? And what on earth does a can of spaghetti have to do with early computer programming?
Yeah.
So that should be fun.
And then that's just the beginning.
Oh, yeah.
We'll also be looking at, the challenges of n-dimensional space.
Okay.
The power and limits of information theory.
Yeah.
And why it's so important to be wary of experts.
Oh, yeah.
Even your own expertise.
So this will be good.
It'll be fun.
Lots to unpack here.
Yeah.
So,
where do we start?
Well, Hamming kicks things off talking about style.
Oh.
Not, in the fashion sense,
Right.
but in how we approach thinking.
Yeah.
He argues that, your style of thinking is what often makes the difference between good work and groundbreaking work.
That's a good point.
And he uses a fascinating example from Bell Labs. There was this group he called the Four Young Turks.
Oh, okay.
Who basically transformed the entire math department's approach to their work.
How'd they do that?
Yeah, how'd they pull that off?
Sounds like a recipe for office drama.
Yeah.
Well, these guys were they were relentless questioners.
Okay.
So instead of just accepting the status quo, they challenged assumptions, they pushed boundaries, and they encouraged everyone around them to do the same.
Okay.
They weren't afraid of shaking things up a bit.
So what can our listener take away from this Young Turks example?
Well, I think it's a prompt to think about your own style of thinking.
Oh, okay.
What are your strengths? What are your weaknesses? What are your go-to problem-solving methods? Are they serving you well?
Right.
Or are they holding you back?
That's a good point.
Yeah.
So next up, Hamming gets into predicting the future.
Oh.
Which seems like a pretty tall order.
Yeah, how do you do that?
What's his angle on this?
Well, he believes that, really good predictions aren't just based on spotting current trends.
Okay.
But on understanding the fundamental forces that drive change.
Right, you have to look beneath the surface.
Yeah, you have to.
Makes sense.
Yeah.
But he also said something that seems a little contradictory.
What's that?
That short-term predictions are always optimistic, and long-term predictions are always pessimistic.
Right.
How does that square with trying to predict the future accurately?
Well, I think it actually reflects a very human bias.
Okay. Yeah.
In the short term, we tend to overestimate our control over events.
So we think things are going to go well.
Yeah, we imagine things will go well.
Yeah.
But as we look further out, we start to see all the complexity of the world.
Right.
How much is outside our control?
Yeah.
And then pessimism creeps in.
Yeah, it's like, we'll launch that product in a month. No problem.
Right, exactly.
But a year out, will humanity even survive that long?
Yeah, exactly.
We're all doomed.
Well,
maybe not.
Maybe not.
So,
So Hamming brings up this idea of a standard 6% interest growth rate.
Okay.
To show the power of compounding over time.
Okay.
And this applies to knowledge as well.
Oh, interesting.
Yeah. So, small, consistent gains in understanding can add up to huge results down the line.
So even if it feels like we're making slow progress, those little bits of learning do really compound over time.
They do.
Okay.
It all ties back to this idea of developing foresight.
Okay.
We need to see beyond that immediate horizon. And to do that, Hamming suggests asking 3 key questions.
Okay.
But any future we're envisioning.
Okay, what are those?
What's possible?
Okay.
What's probable?
Uh-huh.
And what's desirable.
Okay.
So this helps us move from wishful thinking to realistic planning and focus on what matters.
So I could be applying that to anything from my career path.
Absolutely.
To I don't know the future of my favorite sports team.
Exactly. It's a framework for strategic thinking.
Yeah, that makes sense.
Yeah.
So now a big chunk of the book is about the rise of digital computing.
Right.
Why was that so central for Hamming?
Well, he saw computing as more than just a tool.
Okay.
It was a force that completely transformed the technological landscape. To understand its impact, he felt you had to go back to the beginning.
Okay, so he traces this evolution.
Yeah, from early analog devices.
Okay.
Like slide rules.
I've seen those in museums, kind of like a super ruler.
Exactly.
Yeah.
Then he goes on to, more complex machines like the differential analyzer.
Oh, wow.
Which Hamming himself used in his early work.
This sounds pretty primitive compared to what we have today.
They were.
Yeah.
But each step paved the way for the digital revolution.
All right.
And Hamming even shares a funny story about how he finagled his way into getting a computer for Bell Labs.
Really?
He deliberately rented outside computer time.
Oh, wow.
Making it more cost-effective for his boss to buy their own machine.
That's some strategic thinking.
Yeah.
So when did things really take off in the digital world?
Well, the turning point was these machines like the ENIS and EDVAS, these massive room-filling computers.
Oh, wow.
That really launched the digital age.
Okay.
Then came the IBM 650, which Hamming used extensively.
Okay.
Yeah, it's incredible how fast the field was developing back then.
Yeah.
Capabilities were doubling every 15 to 18 months.
Makes you wonder if we're still on that exponential curve today.
Yeah.
Or if we're approaching some kind of plateau.
Right.
But let's be honest.
Yeah.
Those early computers weren't exactly user-friendly.
No, not at all.
Right.
Early programming was like navigating a maze blindfolded.
Oh, wow.
They were writing instructions in pure binary code.
Oh, yeah.
Just ones and zeros.
Wow.
Resulting in what Hamming called spaghetti code.
Oh, yeah, you can't follow that.
Imagine trying to debug that mess.
Oh, man, yeah, good luck with that.
Yeah.
But hey, at least job security was good back then.
You would think so, but Hamming tells this story about how he introduced a much simpler symbolic programming system to a group of programmers. And almost nobody wanted it.
Why is that?
They were so used to doing things the hard way.
Oh, wow.
That they actually resisted change.
Oh, that's so human.
Even when it made their lives easier.
Yeah.
It's a great lesson in how powerful inertia can be.
Right.
Even when faced with a better way of doing things.
We humans can be creatures of habit.
Yeah, we are.
Even when those habits make us miserable.
Yeah, exactly.
But Hamming wasn't the type of guy to accept the status quo.
No, he was always looking.
He was always looking for ways to push the boundaries.
Yeah.
He even found a clever workaround.
Oh, really?
To make a basic IBM 650 act like a much more advanced machine.
Wow.
Overcoming its limitations through sheer ingenuity.
It makes you think about those times when you've had to jerry-rig a solution.
Yeah. What did you learn from those experiences?
Good point.
It's amazing what you can accomplish with a little creativity and a refusal to give up.
Absolutely.
Right.
And that leads us to one of the hottest topics today.
Okay.
Artificial intelligence.
Right.
It's generating a lot of excitement.
It's everywhere these days.
It is. Yeah. And let's be honest, a bit of fear as well.
You can't escape it these days, but can machines truly think?
Yeah, that's the million-dollar question.
Right, and Hamming dives right into this thorny issue.
He does.
He explores both sides of the argument.
Yeah, the folks who believe there's no fundamental difference.
Right, the AI is going to take over the world crowd.
Exactly. And then there are the skeptics who argue that, certain aspects of human consciousness, like creativity and intuition, simply can't be replicated by machines.
So is Hamming Team Skynet or Team Humans are still superior?
Well, he doesn't really pick a side.
Okay.
But he offers some really fascinating insights.
Yeah.
Based on his own experience.
Okay.
For instance, he worked with these expert systems, which were early attempts at mimicking human expertise. And he found that sometimes they worked brilliantly, but other times they failed miserably.
Oh, wow.
In seemingly similar situations.
So even in those early days of AI, there was this element of unpredictability.
Right.
It makes you wonder, what are the implications of AI becoming increasingly integrated into our lives?
What are our hopes and concerns?
It's a big conversation.
Yeah, a conversation we definitely need to be having.
It's a bit mind-boggling to think about.
Yeah.
But before we get too lost in the potential AI apocalypse, let's shift gears a bit.
Okay.
Hamming points out that computers aren't just about crunching numbers.
Right.
They've branched out into some much more creative fields.
Absolutely. He highlights this work.
Yeah.
Of these pioneers like Max Matthews and John R. Pierce.
Okay.
Who were using computers to synthesize music.
Oh, wow.
At Bell Labs.
I remember reading about that.
Yeah.
It's amazing to think that even incredibly complex sounds can be represented digitally.
It speaks to the versatility of computers.
All right, it's a tool.
Yeah, it's a reminder that technology in itself is neutral.
Right.
It's how we choose to use it that determines its impact.
Right, so we can harness its power for creative expression or for more practical applications.
The possibilities are really endless.
Yeah. What are some creative or unexpected uses of computers that you've come across?
Constantly.
It's a never-ending source of fascination.
It is.
But now, get ready for a conceptual roller coaster.
Oh, boy.
Because Hamming is about to take us into the world of n-dimensional space.
Okay.
N-dimensional space.
This is where I tap out.
This is where you tap out.
Yeah, math isn't really my forte.
Yeah, it's a real challenge to our everyday intuitions.
Yeah.
So n-dimensional space.
4 dimensions, 5 dimensions.
Yeah.
What does that even look like?
My brain is already hurting.
I know.
Yeah.
But,
it's hard to visualize.
Yeah.
But the key takeaway here is that our 3D intuition can be totally misleading in higher dimensions.
Hamming describes this phenomenon called the circle paradox.
The circle paradox.
Where a sphere in n dimensions can actually escape what seems like an enclosing cube.
A sphere escaping a cube?
Yeah.
How is that even possible?
Well, it all comes down to how distance is defined in these higher dimensions. You know, we're used to thinking about distance as the shortest straight line.
Right, between 2 points.
Between 2 points. But in higher dimensions, there are many more paths.
Oh, okay.
Some of which can be surprisingly short.
So it's like finding a shortcut through a wormhole or something.
Yeah, that's a fantastic analogy.
Okay.
It's about shifting your perspective.
Right.
And realizing that there might be completely different ways of approaching a problem. Even ways that seem counterintuitive at first.
This is all very abstract.
It is.
What's the practical takeaway for someone who isn't a mathematician?
Well, it's a reminder to be willing to challenge your assumptions.
Okay.
Sometimes the most innovative solutions come from looking at a problem from a completely different angle.
That's happened to me before.
Oh, yeah.
Sometimes you get so stuck in one way of thinking, you can't see the solution right in front of you.
Right.
It's like you need to shake up your mental snow globe.
Yeah, exactly.
To see things clearly.
And that's a perfect segue into our next topic.
Okay.
Information theory.
Ooh.
Get ready to explore the fascinating world of bits, bytes, and the limits of communication.
Sounds exciting. Yeah. Let's dive in.
Right.
Welcome back to the Deep Dive. We're continuing our exploration of Richard Hamming's The Art of Doing Science and Engineering.
It's a book that really makes you think.
Yeah, it's packed with insights that go way beyond, just the technical stuff.
Yeah, it gets you thinking about how to approach your work, your life.
Yeah.
In a way that leads to, more meaningful contributions.
Right.
Breakthroughs even.
So before we jump into the next batch of insights, let's do a quick recap for our listener. What were some of the big takeaways from our last discussion?
Well, we talked about how crucial style is when it comes to thinking.
Right.
It's not just about what you know, it's about how you approach problems, challenges.
Right.
We also talked about the importance of cultivating foresight.
Yeah.
Being able to look beyond the immediate and anticipate future trends and possibilities.
Right, and we can't forget that cautionary tale about experts.
Oh, yeah.
Sometimes being too deeply entrenched in a field can blind you to new ideas, breakthroughs.
Absolutely. It's a reminder to always question your assumptions.
Right. Even your own.
Even your own.
And we also got into the nitty-gritty of the digital revolution.
Right, starting from those clunky early computers.
Yep, with their spaghetti code.
Yeah, and then that mind-boggling world of n-dimensional space.
Yeah, my head was spinning.
Yeah, I know.
All fascinating stuff.
It is.
But Hamming doesn't just stick to the technical side of things. He also delves into some pretty profound philosophical questions. Like what?
Well, for example, he explores the idea of whether machines can truly be creative.
That's a question that's puzzled philosophers and artists for centuries.
What's Hemming's take on this?
Well,
he doesn't offer any easy answers.
Right.
But he brings in his own experience.
Yeah.
As someone who is incredibly creative.
Yeah.
He points out that we often define creativity by the value of the creation.
Okay.
But value is subjective.
Right. What's a masterpiece to one person might be junk to another.
So if it's not just about the end product, how does Hamming define creativity?
Well, he suggests it's about finding new and surprising solutions to problems, even if those solutions aren't immediately recognized as brilliant or valuable. It's about making those unexpected connections.
Right. Seeing patterns that others miss.
It's like those aha moments when suddenly things click into place.
Exactly.
In a new way.
And Hamming stresses the role of analogy in this process. We often have breakthroughs by applying knowledge from one field to another.
Right, by seeing parallels that nobody else has noticed.
It's like using a metaphor to explain a complex idea.
Right, suddenly something abstract becomes clear, relatable.
He even makes a rather provocative comparison.
Oh, yeah.
Saying that creativity is probably like sex. You can read all about it, but you won't truly understand it until you experience it firsthand.
Well, that's quite a statement.
Yeah, but there's truth to it.
There is. Creativity can't just be learned by, memorizing facts or following rules.
Right, you have to get out there, experiment,
risks,
make your own discoveries.
Which leads us to the topic of failure.
Right.
Hamming doesn't shy away from discussing his own mistakes.
Well, that's good.
He believes we can learn just as much, if not more, from our failures.
Absolutely.
That's from our successes.
It's about reframing failure as a learning opportunity.
Right.
Not a sign of defeat.
He even tells a story about how he missed out on discovering the fast Fourier transform. Which is a really important algorithm in digital signal processing. Because he was so focused on his own preconceived ideas.
That's humbling.
Yeah, it's a humbling reminder that even brilliant minds can get stuck in a rut.
So what's the lesson here for our listener?
Well, it's about being humble enough to learn from anyone. Even if they're not considered an expert in your field.
Right.
Sometimes the freshest perspectives come from those who are outside the established way of thinking.
Right.
That ties back to what we were discussing earlier about being wary of experts.
Yeah, Hamming dedicates a whole chapter to this.
He does. He acknowledges that, experts are obviously important.
Right.
But he cautions against blindly accepting their pronouncements. Especially when they're declaring something impossible.
So he's basically saying that experts can be wrong.
Yeah, just like anyone else.
Just like anyone else.
And he gives a bunch of examples. Like those who insisted that heavier-than-air flight was impossible. Right before the Wright brothers took to the skies.
That's a classic example.
What other instances does he bring up?
Well, there was the initial resistance to the theory of continental drift.
Oh, right.
Which just didn't fit with the prevailing understanding of geology at the time. And even the belief at one point that you couldn't lift water more than 33 feet.
It's amazing how what seems impossible in one era can become commonplace in another. So how do we avoid falling into the trap of believing experts without question?
Right.
Even in our own fields?
Well, Hamming encourages us to think critically about the basis for any claim, especially when it comes from an expert.
So what assumptions are they making?
Yeah, what evidence are they using? And are those assumptions and that evidence still valid?
Right.
In light of new discoveries or new technologies.
It's like being a detective scrutinizing the evidence before drawing any conclusions.
Exactly.
But what about the data itself
right.
that experts often base their claims on?
Yeah. Is all data created equal?
That's another crucial point that Hamming emphasizes.
He dedicates a whole chapter to the topic of unreliable data.
So it's not just about questioning the experts,
right.
but also questioning the information.
Yeah, the information they're working with.
Precisely. He provides tons of examples of how data can be misleading.
From simple errors in measurement to biases in the way data is collected, or even outright manipulation.
That's a bit scary, to be honest. How do we know what data to trust?
It's definitely a challenge.
Yeah.
Hamming doesn't offer any, easy solutions.
Right.
But he urges us to be skeptical of any data, especially when it's presented without proper context.
Right.
Or when it seems too good to be true.
Yeah, if it sounds too good to be true, it probably is.
He also stresses the importance of understanding the limitations of any measurement system.
So we shouldn't just take numbers at face value.
No.
We need to understand where they came from, how they were collected, and what they actually represent.
Exactly. Yeah. It's about being aware of potential biases and looking for that full picture.
Now, for our listeners who are engineers or aspiring engineers, Hamming has a whole chapter dedicated to systems engineering.
Oh, yeah. Systems engineering.
What's his perspective on this field?
Well, he sees it as essential for tackling, these increasingly complex challenges we face in the world today. He traces its roots back to the development of the telephone system.
Oh, wow.
Which was one of the first truly large-scale engineered systems.
So it's about understanding how all the different parts of a complex system interact.
Yeah, and how to design those parts to work together effectively.
And Hamming emphasizes that it's not just about building physical things. It's also about the human element.
Right. Systems operate within social and organizational contexts.
So you can't just focus on the technical specs.
Right, you have to consider the people involved as well.
One of the biggest challenges, he argues, is preventing individuals from optimizing their own little part of the system at the expense of the overall goal.
At the expense of the whole thing.
So it's about seeing the bigger picture.
Yeah, the interconnectedness of things.
It reminds me of how often projects fail.
Oh, yeah.
Because people get so focused on their own narrow goals that they lose sight of the overall vision.
That's a classic systems failure.
Yeah.
Hamming gives examples from his own experience. Showing how systems thinking can lead to much better outcomes.
Right.
He also stresses that systems engineering is never truly finished.
It's ongoing.
Yeah, as the environment changes.
Right.
We need to adapt and refine those systems.
So it's about embracing change.
It is.
And continuous improvement.
Always looking for ways to optimize the system as a whole.
But Hamming doesn't just focus on the technical aspects.
Right.
He also explores some deeper philosophical questions about complex systems.
Like what?
Well, he talks about the limits of human knowledge. And how our own biases can lead to flawed system designs.
Right.
And he touches on the ethical implications of building systems that have a profound impact on society.
Yeah, it's a reminder that we're not just building machines.
Right.
We're shaping the world.
Yeah, we live in, it's not just about making systems that work, it's about making systems that are truly beneficial.
Yeah, for humanity.
That brings us back to one of Hamming's most famous sayings.
What's that?
You get what you measure.
Oh, yeah, we touched on this earlier.
Yeah, he dedicates a whole chapter to it.
He does. And in this chapter, he really dives deeper into this idea that the act of measuring something can actually change the thing being measured.
Can you give an example of what he means?
We'll consider schools that are obsessed with standardized test scores. This can lead to teachers teaching to the test, narrowing the curriculum, neglecting other important aspects of learning.
So instead of promoting, well-rounded students, the measurement system incentivizes this narrow focus on just test performance.
Exactly. Another example is companies that are fixated on quarterly profits. This can lead to short-sighted decisions that sacrifice long-term growth or sustainability.
Yeah, it's a powerful reminder that what we choose to measure has a real impact on behavior and outcomes.
Hamming argues that we need to be much more mindful of the unintended consequences of our measurement systems.
So how do we design systems that actually encourage the behaviors we want rather than driving us towards the wrong goals?
That's the million-dollar question.
Yeah.
Hamming doesn't offer any simple solutions, but he urges us to think critically about the metrics we use and consider their long-term impact on individuals, organizations, and society as a whole.
It's a call for greater awareness.
It is.
And responsibility when it comes to how we measure and evaluate things.
Yeah, we need to make sure our metrics align with our values and our vision for the future.
Well said.
Unfortunately, that's about all the time we have for this part of our deep dive.
But don't worry, we'll be back soon.
We will.
For the final part of our exploration of Richard Hamming's insights.
Until then, keep those minds sharp.
And remember, don't believe everything you hear.
Oh, yeah.
Even if it comes from an expert.
We'll see you next time.
Welcome back to the deep dive. We're wrapping up our exploration of Richard Hamming's The Art of Doing Science and Engineering.
Yeah, it's been a fascinating journey.
Yeah, this book has been a real eye-opener.
So many great insights.
Yeah, packed with insights that go way beyond, just technical skills.
It really is about thinking differently.
Yeah, so we've covered a lot of ground.
We have.
The power of style and thinking, the importance of questioning experts, the dangers of unreliable data, the challenges of building complex systems.
And so much more.
Yeah, and so much more. We've explored some pretty mind-bending concepts like n-dimensional space.
Oh yeah, that's a fun one.
And the nature of creativity.
Yeah.
But in this final section, Hamming brings it all together and offers this really powerful message about what it takes to do truly great work.
What's his secret sauce?
Well, he challenges us to strive for excellence.
Okay.
He seems to believe that achieving greatness is more attainable than we often think.
You know, it's funny because one of his key points is the importance of working on important problems.
That sounds obvious.
It does, but I think, a lot of us get caught up in the day-to-day grind.
Yeah.
And we lose sight of the bigger picture.
It's easy to get bogged down in the details and forget about, the impact we want to make. It's exactly. Hamming reminds us that, if we want to make a real difference, we need to focus our energy on problems that truly matter.
Right, so set ambitious goals.
Yeah.
Step outside our comfort zones. Aim for something truly meaningful.
He tells this great story about how he challenged this group of chemists at Bell Labs to work on more significant problems.
Yeah.
And one of them ended up becoming head of the group.
So it's about, taking initiative.
Yeah, going for it.
Putting yourself out there.
Absolutely. But, Hamming also acknowledges that tackling important problems isn't always a smooth ride.
There are going to be roadblocks.
There will be setbacks, obstacles, even failures along the way.
He's not sugarcoating the path to success.
Not at all, but, he encourages us to see those challenges as opportunities for learning and growth.
So it's about having the resilience to bounce back from those setbacks.
Yeah, to keep pushing forward.
And keep pushing forward. Exactly. It reminds us that, even the most successful people have faced their share of failures.
Right. It's not about avoiding failure altogether.
No. It's about learning from those experiences and coming back stronger.
So it's about having the courage to take risks.
Yeah.
Knowing that you might not always succeed.
Right. But the journey itself is valuable.
Now, in addition to working on important problems, Hamming emphasizes the importance of cultivating a prepared mind.
Okay. What does he mean by that?
Well, he's talking about the importance of continuous learning.
Okay.
Constantly expanding your knowledge and skills.
But being curious.
Yeah, exploring different fields.
Connecting the dots.
Yeah.
Between seemingly unrelated ideas.
So it's not just about acquiring knowledge, it's about being able to apply it in new and unexpected ways.
Exactly. He encourages us to be, voracious readers.
Oh, yeah.
Attend lectures, engage in discussions, always be seeking out new information, new perspectives.
Yes. So it's about being a lifelong learner.
It is.
Always challenging yourself to grow and evolve.
Right. And, it's also about being willing to step outside your own narrow area of expertise.
Right.
Learn from others.
Yeah.
Even those who aren't considered experts in your field.
Okay, so Hamming's final piece of advice is to seize opportunities when they arise.
Oh, this is a good one.
He believes that opportunities are all around us.
Yeah.
But we often fail to recognize them.
Right. Or we're too hesitant.
Or we're scared.
To take advantage of them.
So it's about having the courage to say yes when a door opens.
Even if it leads into the unknown.
Right, even if it's a little scary.
And it's also about being proactive.
Yeah.
Creating your own opportunities.
Right, don't wait for something good to happen.
Go make it happen.
So take ownership of your career and your life.
Exactly.
Yeah.
Hamming encourages us to set ambitious goals and create a plan for achieving them.
Right. And he reminds us we don't need permission to pursue our dreams.
That's a really empowering message.
Yeah. We all have the potential to do great things.
We do.
If we're willing to put in the effort and take a few risks.
Hamming's book provides a kind of blueprint for success.
Yeah.
But it's not a recipe to be followed blindly.
Right. It's more about a way of thinking.
Yeah, it's a call to think deeply about our work.
Yeah.
Our lives, our place in the world.
It challenges us to be bold in our thinking.
To strive for excellence.
Yeah.
And to make a real difference.
He reminds us that we only have one life to live.
Right.
it's up to us to make it count.
Well, I think that's a fantastic note to end on.
Yeah, I agree.
As we wrap up our deep dive into the world of Richard Hamming.
His insights are so timeless and relevant.
Yeah, for anyone who wants to, make a meaningful contribution
to the world.
As we navigate this increasingly complex and rapidly changing world,
yeah,
his wisdom is more valuable than ever.
So as Hamming would say.
Good luck.
Good luck, and may your thinking be clear.
And your impact.
And your impact be significant.
Thanks for joining us on this deep dive.
We'll see you next time.